So what you're seeing right there, ladies and gentlemen, is a double slit experiment result. So what you're seeing is the screen. The whiteboard in the classroom is a screen, right? I had to cut off the lights so you can actually see the red dots appearing on the screen. The red dots are representing the bright fringes. We are using a red laser in case you need to find the value of lambda. You look for the wavelength of a red laser. So we're using a red laser, and what you're seeing right there is a projection of the bright fringes onto the screen. The screen, again, is our whiteboard in class. So if we were in class, what you would have done is you would have taken a piece of paper, map out these bright fringes, right? Map them out using a pencil, and then go to your desk and use the mapped out fringes to do the measurement. Okay, so I'm just going to do this so you can see and eventually collect your own data at home. So here's my white piece of paper that I put on the board, right? And then I take a pencil and I map out my fringes. Okay, like that. You keep mapping them out. You map quite a number, right? All right, there I have 1, 2, 3, 4, 5, 6, 7 of them mapped out. That is a total, if I had to sum them up, that's a total of 7y. So if I can measure this distance and divide by 7, I will know what y is, okay? So let's go ahead and measure that distance using a caliper. We're going to get away from the board and do it on paper. So let me turn on the light and I'll be right back with you guys, all right? As you can see, with the lights on, you cannot see those bright fringes, okay? So now, the next step here, you see the class is empty, I'm all by myself. Never knew I would teach a lab without students inside, but you never say never. So I'm going to put my setup in place so you can see me measuring the size of my fringes, okay? Can you see that? I hope you can, all right? I'll take this down a little bit. I think everything here is mechanical. I don't have the fancy gadgets you probably have at home. My wife has a lot of those things to make videos, but I don't have any. So you bear with me doing things using my lab equipment here. Alrighty. So right there you have my 7 fringes mapped out. I mean, they're not perfect, but they're good enough. All right, you see they're all almost the same size because with the double slit experiment, the central, maxima, and all the other ones have the same size. So here is my caliper, which I'm going to use to measure the distance from here to there. All right, so I put my caliper. Let me bring that down here. All right. I don't know if you guys can really see here, but from the look of things, we are somewhere between 6.7 and 6. Yeah, we're somewhere between 6.7 and 6.8 centimeters, okay? Now, you know how the caliper works, so I have to look at the sliding scale to figure out what that decimal is. And I'm just going to do it, you know, because if I ask you to do it, it wouldn't make sense. But what you can see is if you look right here, my 0 really maps out 7. Let me adjust this a little bit. I think I'm being too generous here. No. Okay, I want to believe that's the best I could pull out in terms of adjusting the caliper. So again, I'm somewhere right above 6.7. All right? Actually, maybe 6.7, maybe 6.6. We'll see. Let's look at the sliding scale. When I look at the sliding scale, I have 5 here, if you look at the sliding scale, the marking number 5 is relatively aligned. Well, I would say 5.55 is right here. So 5.5 here, no 5.4, 5.4 here is perfectly aligned. So my dimension is 6.654. You get it? 6.6. Okay. No, not 6.6. It's 6 point. I'm looking at the zero marking here. Okay, that's 6.8. Then the precision, I look for the precision on the sliding scale, and that precision corresponds to 5.4, 6.854 centimeters. Make sense? Y'all should know how to use a vernier caliper by now, so I'm just kind of rehearsing the whole thing here for you. Again, I measured 7 bright fringes. I used my vernier caliper to measure the length, the total length of the 7 bright fringes, knowing that that is the same as 7y, right? So my distance of 7y, according to my vernier caliper, this distance right here is 6. I want to write the number so you can see it. 6.854 centimeters. If I had a good camera, I would have asked you to do the measurement yourself, but I know the image quality is not best. That's why I'm trying to give you the best number here. So 6.854 centimeters is the distance for 7 bright fringes. You do the math. If you have 7 bright fringes and you want to know the size of 1 bright fringe, right? 7y equal that, you solve for y. You know it's a red laser. You can find the wavelength of a red laser on the internet. And I will give you subsequently in your presentation the distance between the light source and the screen. I have to measure that, and I'm by myself, so I will not be able to put the camera and measure the whole thing. So I will provide you with that distance. I'll give you the distance L. But here I've given you what the length of 7 bright fringes is, and you know you're dealing with a red laser, so you can find the wavelength. And with all those tools, you should be able to solve the size of the aperture of the space between the 2 apertures of your double slit experiment. All right, thank you.